We are prisoners on Earth. The universe taunts us by showing all the places we can't ever visit. However, if a species want to have a long-term future, we have to escape our prison. But what is keeping us here in the first place? Turns out, we owe the universe a debt that is 4.5 billion years ago. Everything with mass in the universe attracts every other thing with mass. We call this phenomenon gravity. The closer you are to a big chunk of mass, the stronger the attraction or the more you are pulled in. This effect traps us on the earth. We can imagine this as being prisoners in a gravity prison or a gravity well. It's not a literal well, but a handy concept to understand how this works. Being in a gravity prison means that you owe gravity energy. But how can you owe energy? Because in a universe, things don't want to change their speed or direction. To convince them to move, you have to expend energy. Billions of years ago, the gravitational attractions of trillions of dust particles orbiting our sun caught them together until they formed a planet. This process used energy and created the gravity well we are now a part of. The deeper you are inside the gravity well, the more energy you owe gravity. If you don't find a way to get enough energy, then you aren't able to live no matter what you do. Because your atoms were once part of the dust that the universe expanded energy onto the get to the place. Okay, let's summarize all of that again. Objects in the universe don't like to move. You have to convince them to do so with energy. Gravity used energy to convince the part of our planet to move together. This created a gravity prison in the process, trapping us. To escape it, we need to repay it with energy. Okay, how do we do that? To get into space, we need to go through a complicated process of exchanging energy. For this purpose, we build a negative potential energy replaying machine, known by the more boring name rockets. Rockets work by using some of the most energetic chemical reactions humans know about to basically explode fuel in a controlled way. This converts chemical energy into kinetic energy. The excess of the reaction is directed outwards and pushes the rockets away from Earth. By expanding a lot of energy, we are increasing our gravitational potential energy, which is a complicated way to say that we are paying back our energy debt to gravity. But it's actually a lot bigger than that. When you burn when you burn a fuel to get into orbit, you lose lots of energy to eat, exhaust and atmospheric drag. So you actually need more and more. And you can't just pile a huge amount of radioactive, really explosive dangerous fuel close to your payload and deny it. You need a controlled burn, which is complicated and makes your rocket very heavy, which means it has more mass. The more mass something has, the more energy you need to convince it to move. So you need more fuel to lift up your rocket. But if you need more fuel, that means you need more rocket to carry that fuel. But this makes your rocket heavier, thus require more fuel, which requires more rocket to carry that new fuel and so on. At that end of this madness, you need closer to 100x the weight of your payload to launch. Ariane 6, for example, the European rocket, will weigh 800 tons and should be able to transport 10 tons into the geostationary transfer orbit or 20 tons into medium Earth orbit. But a rocket can only produce so much thrust, so there is a maximum weight, after which is just won't take off. If you add too much of weight, it won't lift off, so you can't just build bigger and bigger fuel tanks. This is the tyranny of the rocket equation, and it means space flight will never become easy. But wait, it gets worse. Getting to space is still not good enough. You are still inside the gravity prison at the edge of space and will crash back to Earth. To get to a stable position where it can stay for a while, a rocket has to reach low Earth orbit. To do this, you need a lot of kinetic energy, which means going extremely fast, at an altitude of about 100 kilometers. This is 8 kilometers. 28,000 kilometers per hour is fast enough to travel around Earth in 90 minutes. Here we can use a trick. Instead of flying straight up, we can go sideways. Earth is a sphere. So, if you're going sideways fast enough, the ground will curve away beneath you. So, as long as you are above the atmosphere, you will be able to stay up there in orbit. This is what ISS does, expanding energy from time to stay fast enough. If you look at orbits in scale, we see that near Earth orbit is laughably close to Earth. To deploy, for example, satellites on leave for other planets requires another round of energy depth repayment. Getting to orbit is the most difficult part of space flight for us right now. For example, if we want to send a rocket for Mars, half the energy half the energy is necessary just to get into orbit, and the other half for the 55 million kilometers to Mars. Therefore, to be as effective as possible, rockets aren't built in one giant piece. Instead, we use multi stage rockets. We don't need to carry an empty fuel tank so rockets drop it. Rockets today shed their boosters and main stage as they ascend, with each successive stage being its own fully contained rocket, complete with its own engine and fuel. Okay, so this is why getting to space is hard. If you feel all this seems really complicated, don't worry, it's literally rocket science.